At the start of the Threads and Concurrency lecture, we asked ourselves whether threads are useful, and we mentioned there are a number of reasons why they are. They allow us to gain speed up because we can parallelize problems. They allow us to benefit from a hot cache because we can specialize what a particular thread is doing on a given CPU. They lead to implementations that have lower memory requirements and where it's cheaper to synchronize compared to multi-process implementations of the same problem. We said that threads are useful even on a single CPU because they let us hide the latency of I/O operations. However, how did we draw these conclusions? What were the workloads? What were the kinds of resources that were available in the system? And ultimately, what were the different metrics that we were using when comparing different implementations with and without threads? And the way that we would measure whether something is useful or not would differ. For instance, for a matrix multiply application, we want to think about the execution time of an implementation or a solution. Or for a web service application, maybe what we care for is the number of requests per unit of time that we can handle. Now, in the context of that same application, if we think about things from the client's perspective, maybe it's really the response time that can be used to evaluate whether something is better or more useful than the alternative. For these kinds of properties of the system, maybe I want to know their average values or whether they're maximum or minimum values, so their best and worst case values. But also perhaps I'm concerned with just what is the number of requests per time that I can service or what is the response time that I deliver to clients. Most of the time, 95% of the time or 99% of the time. So yes, there may be few outliers, few situations in which my request rate drops. But as long as 95% of the time it's exactly where I want it to be, that's a solution that's good for me. So because of the fact that these outliers, these remaining 5%, may have very different behavior than the rest of the requests or the rest of the time that the service is operating, then when you're using the average numbers for these values, the evaluation may look very different than when we're using the 95 percentile values. Or maybe we're designing some hardware chip, and in that case, really, from the hardware perspective, the thing that we're really concerned with is whether or not the overall utilization of the hardware, the CPU, is better. What these examples illustrate is that to evaluate some solution and to determine whether it's useful or not, it is important to determine what are the properties that we really care for. What are the properties that capture the utility of that particular solution? We call such properties metrics. So basically the evaluation and the answer to whether something is useful or not will depend on the relevant metrics.